Alright, so we're going to be talking about linear patterns today. We're going to talk about linear patterns today. So, in example 1, it says in the diagram below, what is the relationship between the number of triangles and the perimeter of the figure that they form? So we're going to represent this relationship using a table and words. We're going to write an equation and we're going to graph it. So we're going to represent this relationship in 4 different ways. So first, let's do a table. Let's create a table. So, I have a table. But what are the two things I'm comparing? The number of triangles and the perimeter. So do y'all mind if I use T for number of triangles and P for perimeter? Why, thank you. Alright, so when I have one triangle, what's my perimeter? 3 plus 4 is 7. 7 and 3 is 10. Alright, when I have two triangles, I have 3 plus 4 is 7, plus 3 is 10, plus 4 is 14. When I have 3 triangles, 3 plus 4 is 7, plus 4 is 11, plus 4 more is 15, plus 4 is, oh, sorry, that's 14, plus 4 is 18. Alright, finally I have 4 triangles. 4 plus 4 is 8, so I have 2 of those, so that's 16. 16 plus 6 is 22. Alright, so let's see if we can tell what's happening with words. I'm sorry. So, in words, so what's happening every time I add a triangle? Because our perimeter is increasing by 4, right? Oh, sorry, that's a plus 4, plus 4, plus 4. So, every triangle added increases the perimeter by 4, right? Each triangle added increases the perimeter. Bless you. By 4. Okay. So now I want to write an equation to describe this. I think this is the trickiest part. I think the equation is the trickiest part. You ready? So, perimeter is, well, P equals what? T plus 4? Let's try that. So if I say T plus 4, so my number of triangles plus 4. So 1 plus 4 is 5. Is that, oh, no, so that one doesn't work, right? That's okay. That's okay. We're thinking. We're thinking. So it can't be that. Well, let's take a look at our triangles, you guys. Here I've got 4. So if I added another triangle, we're going to add, we added this side here, right? 4. And we added another triangle. That was this 4. I added another triangle. That was this 4. What do all of these pictures have in common? What's the constant? That 3 is a constant, right? 3, 3, 3, 3, 3, 3. They all have the 2 side lengths of 3, right? So we know that no matter what, 3 and 3 is 6. We know we're going to have 6 no matter what, right? So 6, and then we're going to add 4 for every number of triangles, right? So my perimeter is 4 times T, the number of triangles. So let's check that one to make sure it works. So let's do 1. So 1 times 4 is 4. 4 plus 6 is 10. Okay. 2 times 4 is 8. 8 plus 6 is 14. All right, what about 4? 4 times 4 is 16, right? 16 plus 6? 22. So that's my equation. So your equations may take a little bit of guess and check today. Okay? And finally, we're going to graph this function. All right, so down here I'm going to make this my t-axis. Make this my p-axis. So looking at my p's, can I count by ones? 10, I would run out after 10, right? Count by fives? Could I count by twos?
Yeah.
Twos? Okay, let's do twos. So let's say this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. All right, then my t-axis, should I count every box as 1 or should I spread it out some? Spread it out, so like every other one is 1? So now I can plot these. So 1 we have 10. 2 I have 14. 3 I have 18. 4 I have 22. So am I going to connect the dots on this? Is this continuous or is it discrete?
Continuous.
It's continuous? Can I have half of a triangle? So it's going to be discrete, so we're not going to connect the dots. It's going to be discrete because we're not going to connect the dots. Okay, example 2. Example 2 says, the table shows the relationship between the number of photos, x, you take, and the amount of memory, y, in megabytes, left on your camera's memory chip. Is the relationship a linear function? We're going to describe this relationship using words, writing an equation, and by graphing the data. So, first, is this a function? So if I look at my x's, I'm increasing by 1. How do you know it's a function?
It's a constant rate.
It's a constant rate of change because my y's decrease by 3, decrease by 3, decrease by 3. So it is a linear function, right? Is a linear function. All right. So what is happening every time I take a picture? You're losing what?
Memory.
How much memory? 3 what? 3 megabytes. So each picture uses 3 megabytes of memory, right? Each picture taken uses 3 megabytes of memory. All right. So next I'm going to write an equation. So my memory, y, equals, right, y? Y equals 3x. Why 3x?
Would it be x like x plus 1?
Well, we're decreasing, right?
Yeah, but would you get minus after like because plus 1 photo is next?
Okay. So if I have no photos, how much memory do I have? 512. So the memory I'm taking from is 512, right? So I have 512 minus 3 for each picture, right?
3x.
So minus 3x. Perfect. I'm recording. Alright, so let's graph this. So we have my number of pictures, X, and we have our megabytes, Y. But look at my Y values. 512. Am I going to be able to count by ones? Ooh, you want to start at 500? Because if we count by hundreds, going back, those are going to be it's going to be way too small to read, right? Because they're going to be so close together. So, I can break this graph, can't I? Do y'all remember that? Break it so that we're not starting at 1?
Oh, yeah.
So I could start at, what, 500? So then this would be 501, 502, 503, 504, 505, 506, 507, 508, 509. That's not quite enough. Oh, so if I start at 503, okay, 504, 505, 506, 507, 508, 509, 510, 511. It was my phone. So plot those 4 points. Plot those 4 points. This is normal. Yes, ma'am. Bye-bye. All right. Did I say 5010? I'm sorry. 510, 511, 512. So if we plot those 4 points, when X is 0, Y is 512. Oh, wait, but I need to scale my X-axis, don't I?
1, 2, 3.
Uh-huh. Do I want to count every box, or should I do every other box?
Counting every box is too long. Every other box.
Every other box? Spread it out some?
Yeah.
So 1 is 9. 2 is 506. 3 is 503. And it's going to keep decreasing, right? So again, should I connect the dots? No, why not? You can't have half a picture, right? I can't take half a picture, right? Pictures are counted in whole numbers only. All right, if you would, please glue this into your notes for me. And you can title this page Patterns and Linear Functions, but I have the title already there for you, Patterns and Linear Functions.